Our speaker today is Dr. Julie Gould. She is a research entomologist with the U.S. Department of Agriculture Animal and Plant Health Inspection Service, or APHIS. And today she'll be sharing her expertise on emerald ash borer and the potential to manage it with biocontrol. So she has some great information. I suspect the information she shares will prompt a lot of questions. So please feel free to type your questions in the chat as she's speaking. And Julie, go ahead. Thanks for being here today.
Oh, thank you so much. It's a pleasure. In 15 minutes, I'm going to be giving a very broad overview of emerald ash borer biocontrol. I could go on for 2 hours with all the details of this project. I've been working on it for 20 years, so very broad strokes that I'm going to be giving you today. So emerald ash borer was first found feeding on ash in southwestern Michigan in 2002. But it probably was brought in at least 10 years prior. It certainly came from China, and it probably came in solid wood packing material. A tree died in China, they made it into a pallet, it was shipped to the US, and the beetle crawled out. And it was first found near Detroit, Michigan. The adults themselves are beautiful. They're in a group of beetles called jewel beetles. They're beautiful green beetles, and they feed on ash trees, and the adults do not harm the tree. The adults will emerge in June, and they feed on the leaves and mate and lay eggs under the bark flakes. It's the larvae that hatch from these eggs that start to cause damage to ash trees. And these larvae produce serpentine galleries. The galleries get bigger and bigger in terms of how large they get as the larva grows and feeds. And eventually, an ash tree will just become totally riddled with these galleries. And since they're feeding on the phloem, which is between the bark and the hardwood, they basically cut off the flow of nutrients throughout the tree. And within a few years of infestation, these trees will die after being heavily infested. And ash is about 2% of our forest, but where it's abundant, it can be very, very important. It's often a riparian tree, and you can see that in this area next to the river, a lot of these trees are ash, and they're all dead. And this is a very big ecological impact on this location. Also, it has economic implications. Ash is a very popular street tree, and you can see the difference between this beautifully shaded, cool street and a few years later with all the dead ash. And then it costs a lot of money to get these ash removed. Ash wood is used for baseball bats. It's used to make tool handles, so it also has economic impact. And it has cultural implications for the Native Americans as well as economic, because they produce these beautiful ash bark baskets that they then sell. So it's important culturally and economically. So government agencies tried to eradicate EAB when it was first found, and they would cut down and chip up the infested trees. And they also tried implementing quarantines by saying that people could not move firewood, couldn't move nursery trees. But the problem with emerald ash borer is that unlike gypsy moth, where we have a really good pheromone trap, there wasn't a good method for sampling for these beetles to find out where they were. And even though there are chemical products that are really, really good on an individual tree, you can't inject every tree in a forest. And so very sadly, eradication of EAB was not possible. As of December 2022, EAB is now in 36 states, and it has jumped across some pretty broad areas. It moved to Colorado quite a number of years ago, and it was just found out in Oregon, where this little purple dot is right here. This was not natural movement of EAB. This was EAB that was transported by humans, probably in firewood. So sadly, EAB continues to broaden its range, and eradication was not possible. So we have turned to biological control as a possible solution. And that is what I do for a living, is biocontrol. and specifically classical biocontrol, which is collecting parasitoids, which are tiny wasps that attack insects, predators, and pathogens, and we collect them in the native range of the pest to control it in the area of introduction. And this method of pest control can be highly effective. Back in the 1800s, the citrus industry in California almost collapsed because of this insect called the cottony cushion scale. But they released this beautiful beetle called the Vidalia beetle, and you never see cottony cushion scale anymore. It has worked for 150 years, this biocontrol. Cassava mealybug in Africa. Cassava is native to South America. It's very, very important. Sometimes 70% of people's caloric intake is cassava, but this mealybug was introduced and just wiped out cassava in Africa. But this beautiful little wasp was introduced and has totally mitigated the problem. So there are a lot of benefits to biocontrol, but there are also, of course, risks. And the biggest risk of concern is that it would attack native insects. And I will talk about that testing that goes on before release. So when do we use classical biocontrol? Well, we use it when a species is non-native, check for EAB. It's been established for at least 5 years. It's causing economic or ecological damage, and eradication is not possible. Check, check, check. So we did start pursuing biocontrol of EAB, starting actually in 2003. And we did foreign exploration in China and Russia. This is where EAB is native, and you can actually find populations. These are photographs of my colleagues from the Chinese Academy of Forestry sampling what is actually Fraxinus pennsylvanica, which is planted in China and sometimes does get attacked by EAB. And we have found 4 parasitic wasps called parasitoids, and I'll introduce you to them. On the bottom right is an egg parasitoid, Oobius agrilli, very, very tiny, because it attacks EAB eggs, which are about 1 millimeter in size. And it is solitary. 1 wasp grows in each egg. Going to the upper right, we see Tetrasticus planopenisi, which is a larval parasitoid. It is what's called gregarious. If you look at the picture right here, this EAB has at least 50 of these larvae just jam-packed inside. So it produces more than 1 progeny per EAB, and it also has more than 1 generation per year. The one thing you need to know about Tetrasticus is it's a tiny little wasp, and it has a short ovipositor, and it can only attack EAB in small trees. We also, from China, found Spathius agrilli. You can see this beautiful wasp has her ovipositor, right, which is right here, and it's drilling through the bark. And she lays multiple eggs on each EAB, and this is her larvae that have consumed the EAB. And then she produced these larvae spin cocoons in the EAB gallery, emerging to start another generation. So they too have multiple larvae per EAB, and they also have multiple generations per year. This Spathius agrilli was found kind of in the southern part of the range of EAB in China, and we found another species of Spathius, Spathius galeni, in Russia. When we brought these into our secure quarantine in the United States, we did a lot of host specificity testing our native beetles in the same genus as EAB, such as the bronze birch borer and the two-line chestnut borer. And the regulatory agencies found these, all 4 of the parasitoids to be sufficiently specific, and they were permitted for release. We have released now in 31 states, as well as Washington, D.C., and we have releases planned for Oregon in 2003. More than 8 million parasitoids have been released, which is actually amazing when you consider that EAB larvae have to be reared inside ash logs, which, as you can imagine, is a very big production. But we've released lots of parasitoids. But that's not enough. You can't start there. You have to evaluate the success. Is it doing any good? And these are really the steps. We need to know if the insects are reproducing. Are they establishing? And reproduction just means they reproduce in the field. Establishment means they're there year after year. And we assume that something is established if we recover it at least 2 years or up to 8 generations after release. Then are they moving away from the release site? Are they reducing the density of EAB? And how about the survival of ash? That's our ultimate goal. So we've established a nationwide network of sampling using various methods, such as rearing the insects in tubes and collecting emerging adults. We scrape the bark and sift it and look for the tiny, tiny little oobius. We put out these yellow pan traps and screen the insects that are collected in them, and we also peel the bark of the tree. We have found at least one of the species of parasitoids in 125 counties in 22 states. But sadly, recovery does not equal establishment. We do find Spatheus agrillae, as you can see, in 22 counties in 9 states, but it has never established. It does not persist, and we've done studies to find out that it has a dead-end generation in the fall, and it cannot overwinter and persist. We also need to know if things are establishing and persisting. And one of the things, this is way too complicated to get into in a 15-minute talk, but we are finding that Tetrasticus and Spatheus galeni establish better in the north, and it has to do with the EAB's life cycle. And we also know that Oobius, the egg parasitoid, has specific day length requirements for overwintering. So they don't do as well everywhere we release them, but they're all doing really well in northern states. Excuse me. In terms of dispersal, we did a big study near Rochester, New York, and we documented excellent dispersal by Tetrasticus. The gist of these very complicated maps is that EAB started moving from north to south along a greenway near Rochester, New York, and Tetrasticus, which is these red stars, just followed right along. As EAB, which is the green, started moving south, Tetrasticus was moving right along with it. We also conducted a study in Dutchess County, New York, that showed really good dispersal by Spatheus galeni. And we had some sites of our own in Ulster and Greene County, which are on the other side of the Hudson River, and Spatheus just showed up and on its own, and it obviously had flown across the Hudson River to get to our release site. So these parasitoids are dispersing very well. And what about mortality of EAB? Well, again, we're doing lots of studies. We're looking in Michigan, Connecticut, and these are our studies from New York. And what this graph is showing is that we have instars 1 and 2, instar 3, and instar 4. These are the 4 stages of the larval development. And we have multiple sites in central New York, western New York, southwestern New York, and eastern New York. The blue is living EAB, and you can see that in instars 1, 2, and 3, most of the EAB survive. But look what happens in instar 4. These are all the larvae that we collected at 3 sites. Not a single one survived. They were either attacked by Tetrasticus planopenisi, the yellow bar, Spatheus species, the purple, Atanicola species, that's a native parasitoid, and woodpeckers. And again, in southwestern New York, not a single blue, not a single living 4th instar. All of them were attacked by Tetrasticus or woodpeckers. In western New York and eastern New York, there was some survival. So how did this translate into growth of the population of EAB? This graph shows what's called R sub 0. It's a symbol that stands for the net reproductive rate. If the net reproductive rate of a population is 1, it means that each female has 1 female daughter. That's it. If it's above 1, it means she's doubling or tripling the population. If it's below 1, it means the population is collapsing. Remember those 2 sites where we had 0 living EAB? Well, that's this site here, Central New York, in 2019 and 20. The population growth rate was 0. as it was in southwestern New York in 2019 and 2020. And you can see that most of the time, our population growth is right around 1 or below 1. And these are all sites where biocontrol agents were released. And we are finding that also in Michigan and in Connecticut. So we know that the parasitoids are affecting the EAB. What about the regrowth of ash in these long-term biocontrol sites? Well, we have found that not all mature ash have died. Many of them do, but not all of them. And we are also doing transects, looking at the number of ash saplings and seedlings, and we're finding that the number is increasing, especially in the bigger sapling categories. And what this implies is that these big trees are still producing some seeds. They have to be, because ash seeds do not live long at all. So the mortality of EAB from Tetrasticus and woodpeckers is very high in these small trees. But of course, Tetrasticus has this short ovipositor, but we are establishing Spathia scaleni. It's there, and it has a long ovipositor. And our hope is that as these trees continue to grow bigger, this parasitoid can continue to protect ash. So in conclusion then, EAB parasitoids are reproducing and establishing throughout the US, especially in the north. Parasitoids are dispersing away from the release sites. In conjunction with native woodpeckers, parasitoids cause a lot of mortality of EAB. They reduce EAB population growth. Ash is starting to recover at some of our long-term biocontrol sites. And while biocontrol cannot save our large trees, there is hope for maintaining ash as a viable component of North American forests in the future. And I'd like to thank my coworkers, that's Gideon, Simba, and Sazerac. And that is the end of my talk, and thank you for your attention.
Thank you so much, Julie. I'll remind folks to put your questions into the chat. So I'm gonna ask a really quick question first, because this is one I get a lot. I'm surprised no one has asked yet. People want to know, where can I buy biocontrol agents to release for emerald ash borer? What can I do?
You can buy them nowhere. This is being done by the federal government in collaboration with state cooperators. It's very important that we have a whole series of guidelines as to what a good release site looks like. And because the big trees die, it has to have regrowth. You have to make sure nobody's going to come in and cut down the trees. So there needs to be a lot of control over you need a lot of control over the releases, and so that's why we don't work with the public. We work with other institutions.
Great. I think we won't be able to get to all the questions, but let me ask just one more, and we'll get the other questions answered after the fact. How can you tell that a tree is being attacked by emerald ash borer?
Well, you need to look for D-shaped exit holes. There is a native cerambycid longhorned beetle that also attacks ash. It's the red-headed ash borer. It will produce a round exit hole. The emerald ash borer produces a D-shaped exit hole. The larvae, of course, that means you have to peel into the tree, but the larvae also look very, very different. And there are really good resources online. I think I've given you some of them to put in the links that will help people be able to identify, because it can get confusing. If you have a tree that's full of emerald ash borer galleries or one that's full of red-headed ash borer galleries, they get kind of messy, and it can be somewhat hard to tell the difference.
Thank you. So our next speaker is Dr. Betsy Lamb. She is the Ornamentals IPM coordinator here at New York State IPM. And that includes both greenhouses and outdoor ornamental crops like Christmas trees. And so today she will be answering the question, what to do if you find bugs, in quotes, in your Christmas trees. Go ahead, Betsy.
All right, and I apologize for always looking like I'm looking in the air, but that's because I have two monitors and the camera's in one and the talk's on the other one. So the first thing that I always want to say when people start asking about insects in their Christmas trees is don't panic. We don't have any reports of insects that bite or attack humans coming from Christmas trees. And we don't even like to sometimes talk about it because people now associate insects and Christmas trees. And there are some that will be happily in there. None of these giant 8-legged freaks, but there are insects there. But you don't have to like them. Just because they're not going to hurt you doesn't mean you like them. So the next thing is, what are you most likely to see? So, and I put in here that what are you most likely to find on cut your own trees or locally cut trees? If you're buying a tree that's coming from North Carolina or Pennsylvania that's been cut for a while, it's not to say you won't find any insects on it, but it's usually been sitting in a garden center or something for a while. So things may have come after the fact or may still be there. But what we mostly hear about is the ones that are found on locally cut trees. So the three big things that we're hearing about now, and I hear about them. I got my first call yesterday from a grower saying, okay, what do we do? Spiders, praying mantids, and Sonara aphids. And Sonara aphids are kind of new for us, probably within the last 5 years. Usually what you're going to find coming out from in the tree and then hatching from the tree is egg cases, except for the aphids. Because the spiders themselves, it's too cold for them for the most part. So they've gone dormant, but they leave their egg cases behind. And it's true that if you can see them, if you're looking over your tree and you see them, you can just take them outside before they hatch out. The problem, of course, is once they hatch, you tend to get a lot of insects really fast because they've got a whole egg mass hatching. The Sonara aphids, again, are a little bit different, and they're actually on the tree. And you may see when you bring them in, they warm up and they start moving around. They don't really want to be anywhere but on the tree, but sometimes they'll climb off of them. And they're big aphids. They're black. They're shiny. You can tell we all like insects. They're a beautiful aphid, but they are not what somebody wants to see crawling around on their wall. Now, I mean, who could resist the face of a praying mantid? But maybe that's a little different when you suddenly have 50 or 60 climbing up the walls. So what should you do? So if you're buying your tree, either it's pre-cut or you cut it yourself and it's at a local farm, ask to have it shaken. Most growers have shakers. This is a baler. I couldn't find a picture of a shaker that had a tree on it, but they'll usually shake it and then bale it. You can also shake it yourself when you get home. I realize one of the things that makes it difficult to look for egg masses and other things is when you buy a tree that's baled and all wrapped up like this, there's no way you can see anything on the trunk or the branches. And we have a few other kinds of egg masses that are possible. Julie was asking about spotted lanternfly. We also have spongy moth. Haven't heard too many people saying that they've had that. So I'm looking at the big three at the moment. So if you can, cut the baling string while the tree is outside, put it in the stand outside, cut the baling string, look it over, again, shake it some more, and then before you bring it in. Some people say let it sit in your garage or whatever. If it's cold, the egg masses probably aren't going to start hatching. So that may not do much for you. Now, the problem with this code, now you've got things that are hatching and they're crawling on the walls. And the best thing you can do is get a hand vacuum. It's just suck them up and then take that out and empty it outside. Don't squash them, especially the Sonara bugs, because they'll leave you a dark or purple stain. And the questions we always get are from people that have white carpeting or white walls and they've squashed a Sonara aphid. And the one thing that I'll ask you please not to do is please don't spray your tree with insecticides or diatomaceous earth. They're potentially flammable. They're health issues for humans and pets. Your tree's going to sit in your living room. Your kids are going to touch it. Your cat's going to eat it. You don't really want that source of pesticides sitting in your living room. And usually when this discussion yesterday came up is by the time you see the insects crawling all over the walls, they've hatched. They're done. The tree is actually less likely to have insects on it at that point. So there's no point in spraying anything. Just suck them up with a vacuum cleaner. So, and I also like the fact that there is actually a whole legend of a Christmas spider. So we perhaps should be encouraging them in our Christmas trees. But I know that that's a faint hope. So does anyone have any questions? I don't know if I have time for that, but maybe if I do, I'll answer some.
Thank you, Betsy. I want to learn about the legend of the Christmas spider.
I know. I was going to put it. I can send the link to you, and you can send it out.
Yes, please do. If If anyone has a quick question about Christmas trees, you can put that in the chat. I'll just give folks a
That's
minute
the
for
problem
that.
with a 5-minute talk is I can talk really fast.
Yes. All right. Oh, I see a question.
Spruce
Spruce
spider mites.
spider mite.
So spruce spider mites, you can certainly have spruce spider mites in your tree, in the trees. I don't hear people saying, oh, they're coming out of the trees, and they're a cool season mite. So they like it later in the fall and they like it in the spring, but they hide pretty effectively in the winter, and they don't seem to come off the tree when it warms up. So either our growers are doing really good jobs of managing them, or they stay dormant. They don't have, oh, you've seen the webbing. Okay, so that's an interesting thing. So if you're actually seeing webbing, that does sound like they're out there happily moving around the tree, unless it was there when you brought it in.
All right. Well, thank you again to our speakers, Julie Gould and Betsy Lamb. Thank you to everyone for attending. Please remember to register for our 2023 events. Our first event will be on the first Friday of January. We'll be talking about alternatives to simple grass lawn. That may seem like an odd topic for January, but I think January is a great time to start planning things that you're going to plant. That's about the time of year when I want to be thinking about green things. We'll also have a quick 2022 IPM year in review, including some of the photos that you have shared with us. So if you have a great IPM photo that you would like to share, submit to our photo contest, please do that. And hope everyone has wonderful holidays. Thanks.